The floor is yours.
I don't know if you can see my screen.
Yes, perfect.
Right, okay. First of all, thank you very much for the invitation. I'm here today to give you an overview of the, let's say, the key innovations that we are proposing in DESIRE6G, which is the acronym for Deep Programmability and Secure Distributed Intelligence for Real-Time and 26C networks. A few things about the project. Of course, it is in stream B about system architecture. It is a 3-year project with an EU contribution of approximately 4.9 million. We are coordinating as a University of Amsterdam. We are coordinating the project, and Gergely, my colleague Gergely Postgraduate from Ericsson Hungary, is the technical coordinator. A few information about the consortium. We are basically 14 partners spread around 10 different countries in Europe. We have Telefónica's, let's say, our operator. We have different leading industrial partners like Ericsson with 2 subsidiaries, NEC as a provider of solutions, and NVIDIA, our manufacturer of high-performance networking hardware. We have 3 SMEs in the sense of Accelera for providing RAN intelligence solutions, Nubis that is working on lightweight virtualization solutions for edge environments, and TSS for providing security solutions. And we are 1 research institution and 5 leading academic universities with a strong research background in networking, blockchain, and AI. Now, a few things about the project scope. There has been a discussion already, of course, that the 5G systems are falling short on meeting performance requirements for real-time mission-critical applications. For example, high-precision robot control and autonomous vehicles, for example, in the concept of factory automation. So in this, let's say, in this context, and with the goal to promote the 6G vision, DESIRE6G will try to design and develop a zero-touch control management and orchestration platform with native integration of AI to support this new generation of your LLC application requirements over a performant, measurable, and programmable data plane. And towards this direction, I will explain to you a little bit what are the key innovations that we're proposing, but just with related to the applications, our POCs will basically be developed on 2 different testing sites, the Arno testbed in Italy and the 5-tonic testbed in Spain, where in the first case, we're gonna showcase our innovations for a VR for an augmented reality application, where essentially the goal will be to transfer point clouds over cameras from the UAVs to a virtual reality to the headset to recreate 3D objects, for example, in a manufacturing environment. And the second use case will be related to a digital twin of robots, where essentially we have either a robotic arm that we can control remotely or a robot dog, where we'll investigate aspects related to autonomous navigation using SLAM algorithms. And of course, the goal there is to address and the respective latency and reliability requirements. In general, this is a list of objectives that we have listed it in the proposal. I will go into the key innovations because essentially they're explaining what these objectives, what are the objectives that we are targeting. But as a goal, as I said, our goal is to design a functional architecture for the 6G mobile networks in order to support the next generation of your LLC and to try to have an impact or influence vendors and service providers towards the adoption of the principles that we propose through our dissemination and standardization and communication activity. So I will go a little bit into the architecture here. As I said, DESIRE6G is essentially will adopt, on the right-hand side, I list the key innovations. DESIRE6G is targeting to adopt a pure cloud-native approach for mobile network deployment. And essentially what we're going to do is, following the serverless paradigm, we're going to be able to deploy components of distributed applications or network functions on different nodes of the cloud to edge continuum. Okay, and of course, try to exploit the different hardware within the nodes and be able to dynamically migrate them between the different hardware resources. In that sense, here you see we're focusing primarily on how we're gonna try to re-architect, let's say, the mobile networks, is targeting real-time autonomic networking through an architecture that essentially supports a lightweight end-to-end management and orchestration approach with distributed control, which is moved closer to the network nodes, employing multi-agent based systems. So in that sense, as we're pushing it towards a user plane, we're trying to natively accommodate network intelligence closer to the user plane in order to be able to support more fast and more coordinated decision making. A very important, let's say, aspect and axis of our innovation of what we propose in DESIRE6G relates to, let's say, how deep slicing, we're promoting deep slicing in the sense that we want to be able to be used diverse hardware accelerations over a generic hardware abstraction layer. And in that sense, we focus on adopting an end-to-end fully programmable and multi-tenant enabled data plane that will essentially facilitate, enables, and support flexible and customized packet processing operations and protocol support on a per slices basis. So we're talking about end-to-end programmability, basically. Moving, as you see, I move further to the monitoring part. Essentially, our DESIRE6G data control, management, and orchestration planes will be complemented, will be supported by a pervasive monitoring system. And this monitoring system, as we envision it, stretches basically from the network to the user equipment, end-to-end, employing in-network, basically, solutions that will allow us to collect more accurate information, end-to-end information, such as, for example, the overall latency experienced by the UE crossing both wireless and wired links. Now, to address the usual scalability and performance problems that we usually have when we are dealing with centralized collection of such telemetry data, we're going to promote a two-level, let's say, two-stage telemetry approach, telemetry collection approach, where the first stage relates to data collection, which means basically processing and aggregation at the programmable switch or DPU, for example, which will process the data at wire speed, leveraging multiple interfaces or embedded stateful capabilities that the devices have. And in this way, all the amount of data that will essentially receive at the second stage by a telemetry server will be significantly reduced. Which will be on the second stage will be responsible for data storage and further elaboration. Furthermore, we will employ in DESIRE6G distributed DLT, distributed ledger technology, as essentially as a zero trust mechanism at different levels, as you see here, of the architecture. At the higher level, we use blockchain for dynamic federation of services between different administrative domains, whereas at the lower level, we use it to secure the proposed mass-based approach. And the proposed security solution essentially combines automatic security enforcement by binary rewriting and the needed trustworthiness and traceability, which will be provided by the DLT. And finally, the last part, let's say, of our key innovations is related to edge AI. Distributed, essentially, DESIRE6G will employ distributed and privacy-preserving AI approaches to consider application-level requirements, communication, and compute constraints. And towards that end, we're going to investigate a number of different AI techniques, ranging from federated and collaborative learning, covering, of course, both theoretical and more practical aspects from the universities. So, and towards privacy preserving, let's say, and motivated by the same, let's say, innovations that are happening in image processing, we will further investigate data scrambling and normalization techniques in a way to be able, for us to be able to provide third-party intelligent algorithms, for example, with the required data, while at the same time we'll preserve data confidentiality and privacy. And this is, let's say, the key innovations of DESIRE6G. For any questions that you may have, you may contact me directly, or you may contact partners from the consortium. And here is our social media, also available with news about what is happening in DESIRE6G. Thank you very much. I think I'm quite fast.
Thank you, Chrysa, very much in time. Yeah.
Yeah.
And let me add that you have, I mean, the audience also has the chance to ask questions in the chat. I guess, Chrysa, you will remain in the webinar until the end, until
Of
the
course.
Q&A.
Yes.
Yeah. So any immediate questions?